We are discussing about arithmetic progressions. The first thing is, we'll start and do it stepwise. First thing comes is sequence. A sequence is a function whose domain is the set n of natural numbers. They are numbers which are in certain form. They are arranged in certain form like 1, 2, 3 till n. How to represent them? We represent generally, trivially, traditionally by a. So nth term is an. First one will be a1, then a2, then a3 till an. Then we come to real sequence, the arrangement of the numbers where these numbers are real numbers. So now how to represent a sequence? So whenever we represent a sequence, there are two ways. The first way is, I am writing 1, 3, 5 and this goes up to 2n minus 1. And second thing I am writing it as, this is the second way of representing a sequence. 1, 3, 5 till 2n minus 1. This is one method. This is odd number list. This is the one method. The second method is just write an equal to 2n minus 1. This also corresponds to the same list, but the representation is different. Just put n equal to 1. What do you get? You get 2 into 1 minus 1. You get 1. 2 into 2 minus 1. You get 3. A3. 2 into 3 minus 1. 6 minus 1 is 5. Is 5. So you have the same series 1, 3, 5 and this goes up to 2n minus 1. These two are the way of representing a sequence. So whenever we talk about a sequence, whenever we discuss about a sequence, how it is going to become a series, a sequence will become a series, a sequence will become a series. See, if this is a sequence, we have already discussed about this, a1, a2, a3 till an. Now this is a sequence and now there can be a finite sequence, infinite sequence. That is, we have limited number, finite sequence, unlimited number, infinite sequence. So it can be finite, infinite. Now I was telling about your series. Now this is a sequence. How to write this as a series? If I write this as a1 plus a2 plus a3 till an, this sequence will become a series. This is the difference between a sequence and a series. You have made it as a series. What about the progression? We are discussing about progressions now. There is a pattern. There is a sequence. There is an explicit formula which defines a particular sequence is called a progression. If the numbers are written in certain pattern or they formulate or they are written with certain explicit formula, it is a progression. This 1, 2, 3 is a progression. 1, 3, 5 is a progression. All these are progressions. We already saw the progression. At that time we were not knowing. Now we know it to be a progression. If you write 2, 7, 11, 1 by 3 minus 5, this is not a progression because it is not in a pattern, written in a pattern, or neither it follows certain explicit formula. Now, there are two things. First is, let me tell you again, because arithmetic progression, geometric progression, everywhere you will hear this word progression. So first is the proper pattern, second is a function. Coming to arithmetic progression, what is AP? Arithmetic progression. It is a sequence, or a sequence is called arithmetic progression if the difference of a term and the previous term is always same. Difference between term and the previous term is always the same. If I write a1, a2, a3, the difference of the previous term, so a2 minus a1 is equal to a3 minus a2. Now I add one more, a4. That will be equal to a4 minus a3. And all these will be equal to all differences of the term with the previous term is known as D. D is called as a common difference. Sometimes it is also called as constant difference, common difference, represented by D. Now this, when it comes to arithmetic progression, if say I write arithmetic progression 1, 4, 7, 10, what all we are interested in? This is an arithmetic progression. The important thing in arithmetic progression is the first term. We represent it by A. This is the first term. And then subtract 4 minus 1, 7 minus 4, 10 minus 7. That is going to come as D. Common difference. 4 minus 1, 3. 7 minus 4, 3. 10 minus 7, 3. So, there are two things which are defining an arithmetic progression. It is the first term and it is the common difference. Then only it will be a arithmetic progression. So, it can be decreasing also, increasing also. Now, coming to a general term. Arithmetic progression, when we are saying that it is having a certain formula or following certain pattern, so we need to have certain general term. So, general term will be what? General term of an AP, 9, 12, 15, 18. The general term will be A plus n minus 1 into D. From starting to n, the nth term will be from the beginning. If you go from rear, 9, 12, 15, 18, 21, 24, the common difference is 3. Take an example. Let us take an example to understand this. Now, the question is, which of the term is 40? In this sequence, which of the term is 40? How to find this? Which of the term of this sequence, 70, 72, 70, 68? It is 40. What is A here? It is the first term, 72. What is the common difference? 70 minus 72, 68 minus 70. What is the common difference? Common difference is, see, it is negative. Always the term is 70 minus 72. It will never be 72 minus 70. It is minus 2. So now you have, what is the nth term? What is the general term? The general term is A plus n minus 1 into D. A plus n minus 1 into D, that is 72 plus n minus 1 into minus 2. And this is going to be equal to 40. Which term is 40? We have to find n here. And you solve n equal to 17. This is how the question will come. This is the general term. So there are different kinds of questions that you will find in AP. Now, selection of terms in AP. This type of question will contain that there are 3 terms in AP, there are 4 terms in AP, 5 terms in AP, 6 terms in AP. So how are you going to assume these terms? How are you going to assume this term? So just assume, let me make a table form. If the number of terms in the question is given as 3, so the term you are going to take is, whenever it is odd, you will start with A. A should be in the middle. Whenever it is odd, A, left hand side A minus D, right hand side A plus D. A is first term, D is common difference. Common difference of these will be D. Now if you have 4 terms, what are you going to do? A minus D and A plus D should be in the middle. A minus D, A plus D. Here you will have A minus 3D. Here you have A plus 3D. What is the common difference? What is the profit? What is the faida? Why we have taken this? I am going to tell you with a question. The common difference is 2D. Let us complete this. Now we have 5. We have 5 number of terms. When we have 5 terms, I told you when we have odd, we have to start with A in the middle. A, left hand side, right hand side. That is left hand side negative, right hand side positive. So A plus D, A plus 2D. The common difference is D. Common difference is D. Always odd number, common difference D. Even number, common difference 2D. Now 6 terms. We have 6 terms. So we have A minus D, A plus D. We have to start with A minus D, A plus D. And here you have A minus 3D, A minus 5D. So what is the common difference? 2D. 2D is the common difference. Now, I need to tell you a question here because we need to understand how we are going to use it. What is the faida? What is the use of this? So there is a question. Find 4 numbers in AP whose sum is 20 and the sum of their square is 120. Find the number of 4 numbers in AP. So sum is 20, sum square is 120. So how to take these 4 terms? We have to take 4 terms. How to take these 4 terms? This is, see, A minus 3D, A minus D, A plus D, A plus 3D. These are the 4 terms you are going to take. A minus 3D, A minus D, A plus D and A plus 3D. These are 4 terms. The sum of these terms is 20. A minus 3D, A minus D, A plus D, A plus 3D. 4 terms we have taken. So first equation is, addition is 20. You add them. make a plus in between. Take a summation. 20. If you see this, minus 3d plus 3d come, cancel. D will cancel. Only 4a will remain. So 4a will be equal to 20. A will be equal to 20 by 4, 5. How about square? Square it, square it, square it, square it, and then add. And you are going to get, in the question it is given as 120. So I'll just give an example. Just take a minus d whole square plus and a plus d whole square. Just take it. So a minus 3d and a plus 3d, I'm leaving it to you. See this, a minus d whole square, a plus d whole square. Just open it. A square plus b square plus 2ab, like this formula. And this 2 cancel. Only a square and d square remains. So you get 4a square, and in d terms you will get the 20d square. 4a square plus 20d square. This is going to be 120. A already you have 5. Put a as 5. D will be plus minus 1. Now you don't have to stop here. Now you have to find these 4 numbers. Now we have to find these 4 numbers. So a you take as 5. One time you take d as plus 1. One time you take d as minus 1. A, both the time you have to take 5. One time you take d as 1. And one time you take d as minus 1. So put in here, a as 5, d as plus 1. What is the first term? A minus 3d. It is 2. A minus d. 5 minus 1. It is 4. Now 5 plus 1, 6. Now 5 plus 3 into 1. It is 8. Right? Now when you take minus 1, it is going to come as 8, 6, 4 and 2. 8, 6, 4 and 2. So this is how we are going to solve this. Now the next thing is, when we talk about arithmetic progression, sum will always pop up. Sum will always come. Addition will always come. Because this is a series. This is a progression. So what is the sum of n terms of an AP? Sum to n terms of an AP. It is going to be Sn, n by 2, 2a plus n minus 1 into d. N by 2, 2a plus n minus 1 into d. This is the first formula. And if you have a series, you have first term also, last term also. Both first and last terms are given. Again we have a formula. Sn equal to n by 2. A plus L. Directly you put A plus L. A is the first term. L is the last term. A is the first term. L is the last term. Both the formula you can use depending upon the situation. Now I'll take a question to understand how this sum can be found out. Now find the sum of the series. By the sum of the series, you have 5 plus 13 plus 21 and plus 181. You have to find out the sum. So you have first term also, last term also. You have 5, 181, first term, last term. So you have the formula, the second one you use. Sn will be n by 2. A is 5 plus 181. A plus L, A and this. Now here n is coming. How to solve this n? How to solve this n? But the nth term is known to you. 181 is the nth term. The n term. So you can find n. How many numbers are there? So just put this value. A is 5 and common difference is 13 minus 5, that is 8. 21 minus 13, 8. So 181 is 5 plus n minus 1 into d. Solve n. You are going to get n as 23. Put here 23 by 2, 5 plus 181. You will get the sum of 5, this series 5 till 181. This will come as 2139. Very easy सवाल question I told you. बहुत easy सवाल बताया मैंने आपको. But the thing is, there will be NCERT questions when we are going to take when we are actually going to solve the problem. Now there can be another question. That finding the number of terms in an AP when the sum of its n term is given. Now take one more question. Finding the number of terms in an AP when the sum of its n terms is given. So I'll take a question. How many terms of the series 54, 51, 48? So it can be ascending, descending. So how many terms of the series 54, 51, 48? And this sum is to be take, so their sum is 530. So we don't know the L. We only need know the first term. So we'll apply the first formula. Sn will be equal to n by 2, 2a plus n minus 1, 51 minus 54, n minus 1 into d. d is 51 minus 54, that is going to be minus 3. And this is going to be equal to 530. Now we need to find out n. So these are type of question. N is going to come. I will directly write this because a quadratic equation will form. So 18 and 19 will come. So this kind of question will also come. That is, you are given sum, you have to go backwards. Either you have to find A, either you have to find N, like this. Now there are certain properties we need to understand, because these properties are very important. The problem solving will be quite easy. The properties of arithmetic progression. First thing is, if you have a series, A1 to A3, now if you add K to all the terms, K plus K plus K plus K, like this, U plus K, take a constant, add to all the terms, or you subtract K, any constant term, from all these terms, the AP will not change, means it will be in AP. Common difference will also be same. The common difference will be same, the AP remains same, and there will be no difference. You add any term to all the terms, you subtract a single term, constant term, with all the values. Coming to second property. Now you have A1, A2, A3. Now you multiply K with each term. Multiply K with each term. Then also this series will be in AP. But the common difference will change. Common difference will be K into D. Common difference will change KD. Now if I divide each term by K, this will also be in AP. If you divide each term by K, but the common difference will change. Common difference will be D by K. Common difference will be D by K. This is the second property. Third property. So if in a finite AP, the sum of the terms equidistant from the beginning and end is always same and is equal to the sum of first and last term. So if you have a finite AP, the sum of the term equidistant from the beginning and the end is always same and is equal to the sum of first and last term. This is property number 3. So let me write it as A1. The final term is An. Before that, an minus 1, an minus 1. So if you add a2 and an minus 1, that is the second term from the front and the beginning, front and the rear. So a2, a minus 1, just add them. Now you take third term from the beginning and from the rear, that is a3 plus an minus 2. Okay, these two additions will be equal, and this will be equal to what? A1 plus an. First term and last term, first term and last term. This is going to be for this is the, so it has to be equidistant from the front and rear. Take values, add, that will always be equal. And there is one more thing which is very obvious, but this is a property. 3 numbers ABC are in AP if and only if 2B equal to A plus C. 3 numbers ABC are in AP if 2B equal to A plus C. So if ABC are in AP, B minus A will be equal to C minus B. Take B on one side, 2B equal to A plus C. This is your fourth property. What is the fifth property? Fifth property is saying a sequence is an AP if and only if its nth term is a linear equation in n, that is an equal to an plus b, where a and b are constant. So if you have an, the nth term of an AP is an plus b, that is a linear equation. Assume it to be ax plus b. Take it at any other thing, just to understand it better using the previous ideas you have. An plus b. So the coefficient of x, that is the coefficient of x, what is small a? Coefficient of n, what is capital A? This is going to be the common difference. This is going to be the common difference. Let me tell you, a sequence of an AP, if its nth term is a linear expression in n, that is an equal to an plus b, in such a case, the coefficient of n in an is the common difference of AP. An equal to an plus b, a will be the common difference. Now, a sequence is an AP if and only if, this is the sixth one, if and only if the sum of its first n terms is of the form an square plus bn. So this is an is equal to an square plus bn, or ax equal to ax square plus bx. So what is the common difference? It will be 2 times of a. It will be the 2 times the coefficient of n square. 2 times the coefficient of x square. Okay, this is a very important property. Now the next term comes is the insertion of arithmetic means. Now let me tell you insertion of arithmetic mean. What is arithmetic mean? In simple term, if you have 2 terms a and b, what is the arithmetic mean? A plus b by 2 is arithmetic mean. You add them, divide by 2. If you have a plus b plus c, means a, b, c, you add them, divide by 3, that is your arithmetic mean. So if you want to have not one but number of arithmetic means between a and b, that is you have a and b, you have a1, a2, and it goes to an. an arithmetic means between A and B. How are you going to find out? There is a formula. I am going to tell you the exact formula. An equal to A plus n into B minus A by n plus 1. This formula you have to use. A1 will be what? You have to put n in this formula. So A1 to An, these are the different arithmetic means you can put inside A and B. The formula is A plus n into B minus A by n plus 1. Now let me take a question, a quick question. So you have to insert 3 arithmetic means between 3 and 19. 3 arithmetic means you have to put between 3 and 19. How are you going to put it? I'll give you a straightforward answer. So 3, A1, A2, A3. There are 3 values which needs to be in between 3 and 19. A1, A2, A3. So there is a formula, you can directly use it. But one more thing I am going to tell you. See, D is what? D is the last term minus first term. 19 minus 3. Last term minus first term. 19 minus 3. And divided by what? N plus 1. How many? This A1, A2, A3. 3. 3 plus 1 is 4. So 19 minus 3 by 3 plus 1. This is 4. 19 minus 3. This is straightforward. 19 minus 3. How many terms do you want in between? 3. So add 1 to them and divide it. You will get A1 is what? 3 is there. 3 plus 4. Add D. Then you have 7. 7. Then what is the A2? 7 plus again 3. 7 plus 4. Sorry. 7 plus 4. You will get 11. Then what is the other term? 11 plus 4. 15. So you have this term.